this is our team Abtal el Digital. From the GOC, we are presenting our DSD project. It is a calculator game that tests the math skills of the person playing. It has 3 different levels. Each level increases difficulty and decreases in time. And we use some components as FPGA board, breadboard, jumpers, and buzzer, and 2 LED lights, one red and one green.
Now we're going to talk about how the game works. The game consists of 3 levels. The first level is with easy difficulty, as it has 30 seconds for the player to solve. The second level has 20 seconds, and the third level has only 10 seconds. You can access each level using the switches, so you can enter the level, or if you answer correctly, you will move on to the next level. In order to put on an answer, there are buttons where you can type, where you can press, and then the answer, if written correctly, it will appear on the board. If you answer correctly, the green light will turn on and the buzzer will beep. If you answer incorrectly, the red light will turn on and the buzzer will beep. If you take a lot of time to answer, the timer will end and the buzzer will beep.
Now we're going to talk about the hardware part of this project.
Regarding the hardware components, we used a buzzer, some buttons, 2 LED lights, one green and one red, but we ran out of red, and some jumpers. Regarding the buzzer has a positive end and a negative end. We connected the positive end to a port on the breadboard, and we placed a jumper on the same line as this positive part of the buzzer to a certain pin in the FPGA board, while the negative part or the negative leg of the buzzer was connected to our ground. This ground was connected to the ground pin on the FPGA board. Same thing with the lights, the positive part placed on the FPGA board and the negative part in the connected to the ground. The buttons have no positive or negative legs, so we used the same method. One jumper was placed in the same row as one leg and connected to the ground, while another jumper was connected to the other leg and placed on a pin or a corresponding pin for each button on the FPGA board. And now my colleague Tsuri will give you a little talk about how the FPGA board works and how we use it in our project.
Good. And now I'm going to talk about the connection between the breadboard and the FPGA board. For the LED lights, the red and the green, and the buzzer, the same thing happens in the 3 of them. The FPGA sends output to the buzzer and the lights, which is electricity, when the value is 1. When the value is 1, the electricity passes through the wires and gets into the buzzer, which leads to a buzz sound, or in the light case, it lights. Okay. Now, another part is the input buttons. We have here 10 buttons. Each button is corresponded to another value, a certain value. To a certain value. When you press the button, it sends signal to the FPGA board through the wire, but this time it's vice versa, where the input is given from the user, from the breadboard, to the board. And this is handled through code, which now the code part will be presented by my colleagues Arola and Ronnie.
Now we are going to talk about the code. Here we have the inputs. We have inputs from the 0 to 9 for the buttons, and we have a clock, and we have the 2 LEDs and the buzzer, and we have 6 outputs for the 6 numbers on the FPGA board. And we have registers, clock out and clock counter, timers successful for the levels, and another timers. Rola will discuss this. So here we are, this always block is for slowing down the clock, because we are using the 50 megahertz clock in the board. So we have to slow it down to 1 second. And here we take the clock out and we make another always block, and we monitor the negative edge for the clock out. Okay. We have three if statements for each level: level 1, level 2, and level 3.
Once the level starts and the output and the X and the Y are represented on the screen, the timer is started to increment. We have three conditions: that if the input is the correct one, 3; if the input is any option other than 3; and if the timer is reached 30 seconds. If the input is equal to 3, the LED will be set to 1, the green LED, and the other red LED will be equal to 0, and the buzzer is equal to 1. And the output is represented, the correct answer is represented on the screen. If the second option, which is the other answer than 3, the red LED will be set to 1, and the buzzer will also be set to 1. If time is out, which reaches 30 seconds, the red LED will be set to 1, and the buzzer also will be set to 1. Same for level 2, but the timer in this case is 20 seconds. And level 3 is 10 seconds. And these are the cases for the X and the Y, which are the X, which is represented
The equation itself.
at the first output, the 6th one, and the Y presented here. That's it.
البوتنز بس عشان يعرف صراحة.
Wrong answer.
والله طلع صوت.